Okay. There's 11:30. It's time to get started. Okay, I'm just going to go over what's going to be happening today again to start off with as usual. So for today's class, basically we're continuing on with Chapter 11. Last week on Thursday, Tarek should have started Chapter 11 with you. Again, he sent me an email saying sort of briefly what he covered. He wasn't very detailed in the email he sent me, so I'm not entirely sure of everything that he went over, but I'm going to do 15 minutes of review of what he should have covered on Thursday's class, just to sort of make sure we're all on the same page there. And then sort of try to continue on from where he left off, continue on with Chapter 11. He said he started Section 11.2 but didn't finish it, was basically what he said, so I'm going to continue on from there with the second half of Section 11.2. Now in Chapter 11 I'm going to be jumping around a little bit. I just want to talk a little bit about why I'm jumping around before I actually do it. So Chapter 11 starts out with 11.1 on sequences and 11.2 on series, which basically sort of talks about what sequences are, what series are, what the sort of main ideas are that involve them. Now what I'm going to do is, before I go into the middle of Chapter 11 is a whole bunch of these things called tests for convergence. There are a whole bunch of different ways to figure out whether a series converges or diverges. And there's a lot of them, and they can get very complicated and annoying and they don't feel like you're really they don't seem that interesting to me. I'm not particularly interested in the test for convergence part. So what I'm actually going to skip to is I'm going to skip ahead to 11.10 today and talk about Taylor and Maclaurin series. And these are sort of the main type of series we are really interested in. There's a whole bunch of other sequences and series that are in the textbook that they get you to test for convergence in the middle of Chapter 11. Most of them are very not useful. The ones that are useful are these guys, the Taylor series and the Maclaurin series. The reason we're interested in studying series are because of these guys. And so I'm going to talk about these guys first to sort of explain why are sequences and series interesting to us and why are they a part of calculus rather than some other discipline in math. And then I'm going to go back and I'm going to start covering those tests for convergence. So there's two that I'm going to deal with, which is 11.3, which is the integral test, and 11.5, which deals with alternating series. So those are sort of I picked two of the four that are in there because I decided they're both fairly straightforward to cover and they're both fairly useful, and they complement each other well. There are more that are in there that I'm not going to have time to cover. And then once I've done that, I'm jumping back to sections 11.9 and 11.11, which are basically more on Taylor and Maclaurin series. It'll make sense as I go through it, but I just wanted to mention that I'm not covering the sections in order in this section. And the reason I'm trying to do the most important ones first, basically, is my goal. I may not make it to 11.11. I may only make it to 11.9 in this course. That's okay if I do. Again, a week from today is the last class for covering new materials. The Tuesday's the actual last class. The Tuesday after that's just going to be review. So basically my plan is these two you've already covered. This one is today. 11.10 is today. These two are Tuesday's class. And the last two are Thursday's class next week. That's sort of my plan as to how I'm going to break things up. But again, if I'm I might not get to 11.11 depending on how things go. My goal is, again, there is a quiz next week. My goal is to have all these topics on the quiz, everything from 11.1 to 11.5. So 11.1, 11.2, 11.10, 11.3, and 11.5. And this quiz is on the Thursday of next week's class, which is Thursday. Is that the day's the 24th, so it's the 31st. So again, there will be a quiz. It may not cover 11.5, depending on where I get to in Tuesday's class, but yeah, it'll cover as much of this as I can. There is also written assignment number 5. That's due Tuesday, August 5th. It's due on the last day of class. I will have it ready for you by next Tuesday. But yeah, this is where things are looking like with Chapter 11. Basically, half the things that are in Chapter 11 I'm not really going to have time to cover. And that's just the nature of the way things are going. Anyway, so there's a bunch of sections like 11.4, 11.6. What's 11.7 and 11.8? I feel like they may have... Anyways. Yeah, so I'm not covering... Oh, sorry. 11.8 is really the one there that I'm skipping. But basically, yeah. Sorry, 11.8 is one I am covering. Yeah, 11.6 is the strategy one. Anyways, so there's a lot of stuff in Chapter 11 that I'm not going to be covering. It's basically the short answer of it. Any questions before I move on to the review of what happened? Oh, a couple other things to mention. Again, there is the written assignment that's due today. If you don't have it in class to hand in, that's okay. Send it to me by email. So tomorrow, my day tomorrow, I've got to finish marking. I have not finished marking the tests yet. I've got a good part of the marking done yesterday, but I'll have to be finishing that tomorrow morning. Once I'm done marking the tests, then I'm going to start marking the assignments. So probably if you get the assignment to me by noon tomorrow, that should be fine. It's probably the morning we'll be marking the tests, the afternoon we'll be marking the assignments. So if you need that extra time, until noon tomorrow, go for it. Take until noon tomorrow.
Do you have office hours right after this, or?
I will be. After class today. Yeah, sort of. I've got to be in the math center by 2:30.
Okay.
So
I forgot my assignment at home. I live close to here, so.
Okay. Yeah. If you want to run back, probably the best thing is try to find me at the math center.
Okay.
Because sometimes during that time we need to go eat lunch somewhere.
Okay.
Like that's So I may or may not be in my office.
Yeah. Okay.
So, but definitely 2:30 at the math center. I will be there.
Okay.
Yeah. Any other questions before I move into the review of what happened last class? Okay. So what I'm gonna not the problems yet. Review of what happened last class. Other set of slides. Okay. So again, what I'm going to be doing now is I'm going to be reviewing material that covers from last class, and the sections are basically section 11.1 and the beginning of section 11.2. I have a handout for that material. I made one up over the weekend. No, I think it was recently. Anyway, so here's the handout for 11.1 and 11.2. So I'm just going to quickly review this stuff. If you missed last class on Thursday, please try to go over the textbook or find some other way of sort of catching up on the material. But basically, there's two things that were covered in the last class. There's sequences and there's series. So I'm just going to go over sort of what you need to know about sequences. Right? So a sequence is an infinite list of terms, right? A list of numbers. Right? So it could be like 1, 1/2, 1/4, 1/8, 1/16, etc. It could be 1, 2, 3, 4, 5, 6, 7. It could be 1 pi squared, whatever. Any infinite list of numbers is a sequence. There's two different ways you can define sequences. We can call it explicit formula, so like an equals n plus 1 over n. Right? So sort of one formula we can define a sequence. We also call it recursive formula. Now, did you go over recursive formulas last class? Okay, I'm just going to go over that quickly because that was something I think I mentioned, that he should cover, but he may not have, so I saw some shaking his head. So I'm going to quickly go over that. So this thing, an equals n times an minus 1, and a1 equals... This tells you a relationship between one term and the term before it. This tells you what the first term is. So a1 is the way we know to note the first term of a sequence. So the first term is 1. The second term, if we use this formula, a2 is going to be 2 times a2 minus 1, when n is 2. It's going to be 2 times a1. a1 is 1, so 2 times 1 is 2. If you want to find what a3 is, n is 3, an minus 1 is a2. So a3 is 3 times a2. a2 is 2, 3 times 2 is 6. We want to find what a4 is. a4 is 4 times a3. But again, let's use this formula. an is n times an minus 1. So 4 times 3 is 12. And we can keep going like this. We can keep finding the terms of this sequence. So again, recursive formula is another way of defining a sequence. It's a lot harder to find terms using a recursive formula than using an explicit formula, like an equals n plus 1 over n, but it also works. Yes, Dylan?
Oh. Wouldn't that be 4 times 6 would be 24?
Oh, you're right. It is 6. I don't know why I was looking at 0 and I saw 3. Thank you. It is 6. A3 is 6. It's not 3.
So it's
just
just the formula of their n factorial.
Yes, actually, this particular sequence, it turns out the explicit formula of this sequence is n factorial. Again, if you don't remember, factorial means n times n minus 1 times n minus 2. It's basically multiplying together all the numbers from n down to 1. That's the factorial symbol there means.
Are we, during, when Eureka gets up in the class DK cover, the squeeze theorem, are we doing that? Or is that going to be?
No, I'm not going to
Because we skipped that in Calc 1, so I was a bit surprised that we.
Yeah, I'm not. Oh. Yeah, I'm not going to be giving you examples using that on quizzes and tests. So
Okay.
thank you for asking that because yeah, that was that. Anyways, I tried to say these things you don't have to cover. That was not one of the things I listed that you didn't have to cover.
Oh.
So I guess that's probably why you covered it. Anyways, I'd forgotten that was even in here. But yeah, I'm not going to worry about that because I'm trying to get this through this chapter basically quickly. So there's a whole bunch of topics I'm going to have to skip because of that, and squeeze theorem is one of those. Yeah. So the key thing that we are interested in with sequences at this point is whether or not they do this thing called converging. A sequence converges if the terms approach a limit. It diverges if the limit does not exist. When we're talking about a limit, we're always talking about a limit as n goes to infinity. We're talking about the limit of a sequence. So this sequence diverges, because if you look at these terms, they're getting bigger and bigger and bigger and bigger. They're basically going to infinity. So this sequence diverges to infinity. Other sequences like 1, 1/2, 1/4, 1/8, that one converges. All those terms are going towards 0. That sort of idea. So if you want to determine if a sequence converges or diverges, you take the limit and goes to infinity. I'm not going to give you any limits you have to do with the squeeze theorem. The only things I'm going to give you, the hardest thing I'm going to give you that you have to do limits with is L'Hopital's rule. Usually either you can evaluate the limit directly or you can use L'Hopital's rule to find the limit. When you're taking when you're trying to figure out if a sequence converges or diverges. Uh-oh. Anyways, this is formatted wrong. There's supposed to be a division symbol between the 1 and the 9 there, I believe. 30 page 700. Let me just make sure. Wait a second. Yep. Yep. Oh, no, this is what it's supposed to look like. Anyways. So here we have the sequence an equals square root n plus 1 over 9n plus 1. That's what it's supposed to look like. Yeah, there is supposed to be a division symbol. It's supposed to be, here the square root is supposed to be over both of them. This is what happens when you type things up quickly sometimes. Anyway, so the idea is we're trying to ask if this thing converges or diverges. When you ask if a sequence converges or diverges, what you're really trying to do is take the limit and then goes to infinity. Now basically what I'm going to do is I'm just going to work with this thing inside the square root. Right? What does that thing go to? Well, so I'm going to take the limit as n goes to infinity of n plus 1 over 9n plus 1. Right? If I want to take that limit, I plug in infinity on the top and infinity on the bottom, I get infinity over infinity. So I can use L'Hopital's rule. If I use L'Hopital's rule, the derivative of the top is 1, the derivative of the bottom is 9, so the limit here is 1/9. So this whole thing, the inside goes to 1/9. So the whole thing goes to square root of 1/9, which is 1/3. So we could say that this sequence converges to 1/3. Again, I'm not going to give you any sequences where you can't where you need something more complicated than L'Hopital's rule to evaluate the limit. Again, converges is just a fancy word for the limit exists. It exists and it's equal to 1/3. Any questions about this example? Okay, the next more complicated object after sequences are series. Now the difference between a sequence and a series is a sequence is just a list of numbers, a series is a sum of numbers.